Hello there. In this lesson, bonus lesson number 2, we're going to look at compounds that have polyatomic ions and how to name them. That's what nomenclature means. This is part of an ISA in my course, but if it's not for you guys, then use it however you like. So polyatomic ions are molecules. So just like any other molecule, like water, it's got covalent bonds. The only difference is it has a charge. So these molecules with a charge can bond ionically with other ions that have the opposite charge. And so there's a whole host of different compounds that have these types of ions in them. So let's look at some common ones and learn how to name them. So compounds with polyatomic ions are ionic compounds. However, they do have both types of bonds inside of them because the polyatomic ion will be bonded together with covalent bonds, right? So all these lines as part of the polyatomic ion are covalent bonds. And then within the structure of the whole compound, so this is carbonate with two negative charges. So you can have sodium carbonate, and between the sodium and the carbonate ions, you'd have ionic bonds. And so sodium carbonate will have properties just like any other ionic compound. It'll conduct electricity if it dissolves in water. It'll have a high melting and boiling point. It'll form nice crystals. And so it'll have all those properties just like other ionic compounds. So here's a base set of polyatomic ions that hopefully you were exposed to in grade 10 and got used to. These ones go along with a nice little mnemonic. Nice students pass chemistry class. How awesome. And you can assign the charges and the number of oxygens using a pattern. So at least for the first 5 here, you've got oxygen that is attached to each one of those other nonmetals. And the pattern is 3, 4, 4, 3, 3 for the oxygens, and -1, -2, -3, -2, -1 for the charge. And then hydroxide and ammonium are kind of separate. They both have 1 charge, but it's -1 for the hydroxide and +1 for the ammonium. So once you know those, there's a bunch that are similar to the ones that the base set that you learned in grade 10. So chlorate here has ClO3 with a negative charge. So there it is. There's the ClO3 molecule. There's this negative charge. And if you go down on your halogen series on the periodic table, you see that underneath there's bromine and iodine. And so this guy here is bromate. And it has the same formula, just change the halogen, right? So this is ClO3 with a -1 charge. And this is BrO3 with a -1 charge. That's bromate. And so surprise, surprise, this one here is iodate. And it has the same basic setup, IO3 with the -1 charge. Another one that's similar to that is sulfate. Sulfate is SO4 with a -2 charge. So there it is, S and 4 O's. This is sulfate. And if you go below sulfate on the periodic table, you get to selenium. And so selenate has the same structure. It's just selenium. You just stick a little E in there, and that's another polyatomic ion, but it has the same number of oxygens and the same charge associated with it. Alrighty, so let's put all that together. We got magnesium and nitrate. Nitrate's NO3 with the -1, magnesium Mg with the +2, and crisscross applesauce, we get magnesium and NO3 bracket 2. So make sure that you don't forget that when you need more than one of a polyatomic ion that you add the brackets. CaSO4, that's just calcium and sulfate. Iron 2 phosphate, so that'd be Fe, and PO4, this is a 3 negative and that's a 2 plus. So put the 3 down here, put brackets around this whole thing, put the 2 down here, and we'll get rid of these charges up here because you don't want that included in your formula. All right, we got Mn And we got 2 carbonates. Now, one carbonate, CO3, has a -2 charge, and we've got 2 of them. So that means that the total negative charge is -4, which means this manganese has got to be the 4. So it's manganese 4 carbonate. Cupric chloride, ic, that's the higher of the copper charges, which is copper 2. And chlorate, ClO3, has a -1 charge, so it's going to be a 2 for that. We got Pb and OH2, so that means since the charge of hydroxide is -1, we've got 2 of them. That means this lead is going to be a charge of 2, and then hydroxide. And the last one here, ammonium sulfide. Ammonium is NH4, which has a +1 charge. Sulfide is just sulfur, which has a -2 charge, which means we need 2 of these to balance out. There you go. Make sure you get your practice. Okay, so that was a few new polyatomic ions. But here we're going to look at some variations that you can have within the polyatomic ions that you already know. So what happens is that the number of oxygens that is bonded to a central atom can vary. You can have different numbers of oxygens with the chlorine for this example. And then you have to change the name slightly to indicate the difference in the number of oxygens. So all of the ones you've learned so far have ended with ATE, and they have a certain number of oxygens that hopefully you're getting familiar with and you can remember. So the parent are the ones that we've already learned. And so this guy here is sodium chlorate, because that's the parent and the one that we've already learned. Now, if you add an oxygen, then it becomes per, and then whatever it is, 8, right? So in this case, it's chlorate, so perchlorate for the name of this one with the extra oxygen. It's got 4 oxygens instead of 3. If you go the other way and take away an oxygen, instead of an ATE ending, you get an ITE ending. So instead of chlorate, it becomes chlorite. So it's sodium chlorite in this case because it's with sodium. And the other option is that you can take away 2 oxygens. And for that one, you got to stick this hypo in there. So there's sodium again. This time the chlorate has lost 2 oxygens, went from 3 to 2 to 1. And so this is hypochlorite because you took away 2 oxygens from the original. Alrighty, so let's try a few of these ones. So we can see we got a chlorite here, which is ClO, not 3, but 2, and with the same charge. And we got magnesium, which doesn't have any options. So it would be magnesium bracket ClO2, and then 2 of them. Here we've got CO2. Now carbonate is CO3 with the -2 charge. So this is not going to be carbonate, it's going to be carbonate. Carbonite. And this copper, there's 2 of them, which means it's a charge of 1. So this is copper 1 carbonate. Aluminum hyponitrite. All right, so aluminum, of course, is +3. And hyponitrate, so nitrate's NO3, so this would be, you take away 2, so this is just going to be NO, and still have that same charge. So it's going to be Al bracket NO, and then 3 of them when you do your crisscross. So we got BrO2. Now bromate is BrO3, so we took 1 off. So instead of bromate, this is going to be bromite, and this is the nickel with a charge of 2. So nickel 2 bromite. Now we got ammonium perbromate. So per means that you add 1, right? So it's going to be NH4 and then BrO4 because we went from 3 to 4. And both of those are have 1 as their charge. So ammonium's +1, bromate is -1, so you only need 1 of each. The last one here, we've got PO3. You know that phosphate is PO4. So that means that, that this is going to be phosphite. So phosphite. And then the iron must have the same charge as the phosphate or phosphite. So it's going to be iron 3. So now we're going to look at some acids that involve all those polyatomic ions that we just looked at. So hopefully you recall that The acids that are related to the polyatomic ions that you already know, they end up with an ic acid name, right? So nitrate will become nitric acid, right? And all we did is we stuck a hydrogen on there and we dissolved it in water. So that's, again, very important. Make sure that you put the AQ on there to indicate that it is dissolved in water. And so all your acids have to be in water for them to behave as acids. Okay, so this guy here is lost in oxygen, so this is nitrite. And if it ends in ITE, what happens with the ITE is that you give it the us acid name. So instead of nitric acid, this is going to be nitrous acid. And then we're going to have a look at a few others here. This is SO2, and you know that the parent is SO4, so this has lost 2 oxygens. So this is hyposulfite. So since it ends with ITE, then it is hyposulfurous acid. So you just keep the us where the ite was, and hypo goes along for the ride. This last one here is perchlorate, right? So chlorate is ClO3. We've added 1 more oxygen, so this is perchlorate. And so you keep the per, and because it's 8, just like the first one here, it's going to get an ic acid name. So this would be perchloric acid. So once you've got the hang of adding and subtracting oxygens and figured out the names that go with them, all you need to do is, if it ends with an ATE, make it an ic acid, and if it ends in ITE, make it an us acid. Alrighty, well, one more thing with these hydrogen-containing polyatomic ions. You might have noticed that some of those polyatomic ions have a charge that is more than 1, right? So instead of -1, it might be -2 or -3. And that means there's variations in the amount of hydrogens you can have attached to it, and for it to still be a polyatomic ion. So a great example is carbonate, which has a charge of -2. And if you add a hydrogen there, hydrogen you can think of as being a charge of +1. So +1 with -2 means the overall charge of this hydrogen carbonate is a -1. So for every hydrogen you add, the charge is going to go down by 1 until you get to the acid, which has no charge overall. So for the name of this polyatomic ion, you just stick the word hydrogen in there. And so this with the sodium and then hydrogen carbonate, so it's just sodium hydrogen carbonate. And there's actually a common name for hydrogen carbonate. It is bicarbonate. And you might have heard of this one as being baking soda, right? Bicarbonate de soude. It's just like the French. Right, so here is phosphate. Phosphate has a -3 charge. If you add 1 hydrogen, it goes down to -2. If you have 2 hydrogens, it goes down to -1. And so for the one with a single hydrogen, it's hydrogen phosphate, and the one with 2 hydrogens, you call it dihydrogen phosphate. So calcium dihydrogen phosphate, calcium is a charge of +2, dihydrogen phosphate, -1, right? There it is. And so when you do your crisscross, it's going to be calcium, put the bracket, H2PO4, and there would need to be 2 of those. Okay. Okay, let's finish things off. The oxyacids are what we just covered. 2 more types of acids that you'll see in chemistry. One are the most famous ones, the binary acids. First on the list is good old hydrochloric acid. This is the acid that's part of your stomach acid or gastric juice. And it has 1 hydrogen and 1 chlorine. That's what makes it binary. Binary means 2, so 2 elements. All of your binary acids have this hydro prefix along with the ic acid suffix. So for this one here with hydrogen and bromine, it's hydrobromic acid, whereas the one with the chlorine is hydrochloric acid. Basically, you do that for all of your halogens, and there's a few other weird ones, like you can do it with like sulfur as well. Organic acids are molecules that have this COOH part of their structure. Now, if you're taking biology, you'll see this over and over and over again. All of your biological acids, like amino acids and fatty acids, they all have this COOH as part of them. In chemistry in grade 11, we don't see a whole lot of these. Acetic acid is a very common one. That's the acid that you find in vinegar. It's about, I think, a 7% solution in the vinegar. And you can see there's the C, and there's the two O's, and there's the H. This other one here is oxalic acid. Again, in a biological context, you will see this as part of oxalates, and that can form things like kidney stones, which I had one time, which I do not recommend. And so those also will form ionic compounds if you take away the hydrogens on them. All right, so there you go, some common acids that you will see as part of grade 11. Alrighty, let's finish this off. We've got bromous acid, so that's bromate, but one less oxygen, so BrO2 instead of 3. So then you stick hydrogens on there, it's got a charge of -1, same number of hydrogens as the charge, HBrO2, and since it's an acid, we'll put the little AQ on there. This ClO here, chlorate has 3 oxygens, and this is down to 1. So this is going to be one of your hypos. So this is going to be hypochlorous acid. All right, hydroiodic acid. So hydro means it's binary, and iodic means the other one is going to be iodine. And then since it's an acid, AQ. Li2HPO4. You can see there's 1 hydrogen there with the phosphate. So this is hydrogen phosphate, and the positively charged ion is lithium hydrogen phosphate. Now we got magnesium hydrogen sulfate. Hydrogen sulfate is SO4 has a charge of -2. HSO4 is going to have a charge of -1, so that means it's magnesium and then a bracket, HSO4 bracket. You'll need 2 of them crisscross, right? Now this last one here is your oxalate ion, the one we just saw on the previous page. It's got the COOH on either end, and it's good to recognize it in different forms, right? They don't always do it as a structural formula. Sometimes they'll put it all together like this, and so it's just oxalic acid. All right, the last thing here, the little tip, is that all acids are aqueous, but not all aqueous things are acids, right? So this guy here, even though it's dissolved in water, it's aqueous, doesn't make it an acid. It's just an ionic compound that's dissolved in water. However, all the rest of these, the ones with the hydrogen at the beginning, they're all acids. Okay, hopefully that'll become clear as you practice and work your way through the exercises. All right, see you soon.